Hi, my name is Fernanda Gómez. Today I'll be talking about my final key activity, which is about electromagnets. Firstly, defining the concepts that will be alluded throughout this whole project. Electromagnets and electromagnetism, in the simplest way possible, are magnets that work with electricity and a physical interaction that occurs between electrically charged particles, respectively. Now, originally, scientists believed that magnetism and electricity were separate forces, but by the end of the 19th century, this view changed. As research concluded, the positive and negative electrical charges were governed by one force. By 1825, William Sturgeon developed the first practical electromagnet by winding a coil of uninsulated wire around a horseshoe-shaped piece of iron, which was later on dramatically improved by several other scientists, and this both eventually led to the understanding of electromagnetism as a physical concept that could be directly applied by using electromagnets as components of very different devices, from magnetic separation equipment to hard disk to motor to fans to pretty much a ton of things. So yeah, for the methodology, here's a list of the materials I used. Here's a little picture demonstrating how it went down. So firstly, you have to mark a face of a bolt with a permanent marker. Then a small piece of masking tape will secure the first coil of the copper wire. Start from the previously mentioned mark. And the first bolt will have 50 coils and the second one 100 coils. And for the air core solenoids, 3 inches pieces of a syringe will be cut. Then one of its places will be marked again, as how I mentioned before. And we'll make one with 50 coils and the second one with 100. Then the syringe will be removed from the center of the electromagnets to avoid melting. And to connect the wires to the battery, we'll have to sand the ends of the wire because it's an insulated wire covered with a part of paint. And we'll connect it with the positive and negative poles of the battery, and then repeat the instructions with each of the solenoids, writing down all the findings we had and whatever visuals we could gather. So as well as using this formula in here to show the force of a 50 coil solenoid and a 100 coil solenoid. So these are the variables. The dependent variables are the distance from which it's capable of attracting clips, the number of clips it picks up, and the force of the solenoid. The independent variables is the amount of copper wire coils around the bolt or the syringe. And the controlled variables are the volts of the battery, which is a 9-volt battery, and the other materials that we used in the experimentation. The results are the following. Table 1, we can see the nails attracted by the solenoid. We have 2 columns separating from air and iron-borne cores, and the number of winds they each have, and here are the results. The second table is the magnetic reach. I measured how far away from it could attract nails, and it's the same format as a previous table. And then the final one is the force of the electromagnets that was used using the previously mentioned formula, which is derived from several other formulas. It's using amperes, it's using several other concepts that are handled in physics. So for the results in the analysis, I just wanted to show like a linear or graphic representation of the relationship between the results that we could obtain from the airborne and the iron-borne and the number of winds it had. And I can establish that the magnetic field of an iron core electromagnet is stronger than the one of an air core. The magnetic field is stronger inside the coil and falls rapidly outside of its volume, explaining why the reach of its field is much shorter regarding specifically airborne solenoids. And the field of an iron core solenoid is stronger due to its magnetized iron at the center of its core. So yeah, for the conclusion, I was able to successfully build an electromagnet, and Through mathematical calculations and visual analysis, electromagnetism was finally understood and grasped as a latent and real phenomenon. The analysis of the results graphically displayed that electromagnets um, increase, that an electromagnet's magnetism increases with the number of coils as it increases, and that it has a stronger reach when built with a solid ferrous core. As well as some areas of opportunity from this could basically be having stronger mathematical basis, as I couldn't understand tougher formulas to have a deeper analysis on the numbers and what exactly the magnetic field was of each of the solenoids. But yeah, I think that's something that goes beyond me from the stuff I can handle right now. And the objectives and hypotheses were undoubtedly met, and I was capable of understanding a real-life concept that partakes as the main component of hundreds of electrical devices. I just had to Google devices that use electromagnets, and there was a huge variety of them, and being able to understand how one of them works is truly something I find very important. So thank you. That was the presentation, and yeah.